Hi everyone. Did you know that in the tech industry, the role of a data scientist is often ranked as one of the top jobs around the globe and has been dubbed as the sexiest job of the 21st century? With such high demand, interviews can get pretty intense. That's why today we are focusing on those tough data science interview questions that really test your mettle. For instance, I once heard about a candidate who impressed the interviewers by optimizing their machine learning model right during the interview. We are going to tackle questions like these, the ones that dive deep and really show what you are capable of. So let's kick off and make sure you are ready to stand out in your next data science interview. And just a quick info for you guys.
Craving a career upgrade? Subscribe, like, and comment below. Dive into the link in the description to fast-track your ambitions. Whether you're making a switch or aiming higher, Simplilearn has your back.
If you want to upskill yourself and master data science skills, land your dream job or grow your career, then you must explore Simplilearn's cohort of various data science programs. Simplilearn offers a data science postgraduate program from Purdue University in collaboration with IBM. Through this program, you will gain knowledge and work-ready expertise in skills like prescriptive analytics, predictive analytics, regression, classification, and over a dozen others. If you are passionate about making your career in this field, then make sure to check out the link in the pinned comment and description box to find a data science program that fits your experience and areas of interest. And without further ado, let's get started. So let's start with the data science interview questions and answers. And the number one problem we would be facing is real-world problem solving. And the question one is handling missing data in predictive modeling. So imagine you have given a data set where 30% of the data for a key predictive variable is missing. This variable is crucial for a predictive model. How would you handle this situation to ensure the integrity and performance of your model? And please describe your approach step by step. So starting with the answer, you can start with handling missing data set is a common challenge in data science, and it's important to address it carefully to maintain the accuracy of your model. And here's how you could approach this situation. The number one point could be identify the missing data. So first you need to understand where the missing values are in your data set. You can do this by using a simple code in Python with libraries like pandas. For example, you can use the data.isNull.sum function that will show you the count of missing values in each column. Then you can analyze the pattern, determine if there's a pattern to the missing data. Is it random or is it missing for a reason? This can affect your approach. If the data is missing at random, the methods you use might be different than if the data is missing systematically. So choosing a method for imputation. Let's see the next method, that is choosing a method for imputation. So if the missing data is numeric, you might replace missing values with the mean or median of that column. This is simple and effective, but can be used primarily when the data is missing completely at random. Then comes model-based imputation. Sometimes you can use other variables in the data to predict missing values using a regression model. This can be more accurate but is also more complex. Then we'll use the k-nearest neighbors KN algorithm. But before that, we have a code snippet here that could be used for the implementation of imputation. You could use Python or R. And now moving on, we'll see the k-nearest neighbors algorithm. So this method predicts the missing values based on how closely related the data points are to each other. So after imputation, it's crucial to check how your changes have affected the overall dataset and model performance. Sometimes filling in too many missing values can introduce bias. And then we have visualization. To help understand before and after the imputation, you could visualize the distribution of the variable using histograms or box plots. This helps in seeing how the imputation has changed the statistical properties of the data. And by following these steps, you can handle missing data thoughtfully and maintain the integrity of your predictive model. Now moving to the question number 2, that is based on evaluating model overfitting. So the question is, you have developed a predictive model, but you suspect it might be overfitting the training data. How would you test and address the issue? Please explain your steps and the techniques you would use. So you could start the answer by explaining what is overfitting. So overfitting is a common problem where model performs well on training data but poorly on unseen data, indicating it's too closely fitted to the training data's specific details and noise. So now we'll see a step-by-step guide on how to address this. The number one step is cross-validation. So one effective way to test for overfitting is by using cross-validation technique. Cross-validation involves splitting your training data into multiple smaller sets, that is faults, and then training a model on some of these sets and validating it on the others. So this helps you understand if the model's good performance is consistent across different subsets of data. For example, in Python, you can use the cross underscore value underscore score function from sklearn.model underscore selection. So this is the code, and this is the code snippet of Python that you can use for the cross validation. And here we are importing from sklearn, that is the module, and we are importing cross underscore val underscore score. And here we have used the cross val score function, and then we have printed the average cross validation score. And the next step we will do is running cross validation model. So this is your predictive model that you have already built using scikit-learn. And here's the X train. These are the X input features of your training data, and Y train, these are the output labels of training data. So we are running cross validation model here. This is your predictive model that you have already built using scikit-learn. So X train here, that means these are the input features of your training data. And Y train here means these are the output labels of training data. And CV equal to 5. This parameter tells the function to split the data into 5 parts, that is faults, and the model is trained on 4 of these parts, and the remaining part is used for testing. So this process rotates until each part has been used for testing once. And the printing results, that is score.mean. So this calculates the average of the scores obtained from each cross validation fault. This average score gives you an idea of how well your model is likely to perform on unseen data. A consistent score across different faults suggests your model is generalizing well rather than overfitting to the training data. So now moving to the next point, that is training versus validation error. So plot the training and validation errors as a function of training epochs or complexity of the model. A model that overfits will show a low error on training data and a high error on validation data as it trains further. Then we have pruning the model. If you confirm that the model is overfitting, consider simplifying it. This might mean reducing the number of parameters by selecting fewer features, using regularization techniques like lasso or ridge, or choosing a less complex model. After this step, we will move to regularization technique step. So these techniques add a penalty to the loss function used to train the model, which can discourage complex models that overfit. Then we have common methods that include L1, that is lasso, and L2, ridge regularization. And here's how you can add L2 regularization in Python. So this is the code snippet here. And what we have done here is we are creating the ridge model, and we have applied alpha equal to 1.0. So this parameter controls the strength of the regularization. A higher alpha value increases the regularization effect, which helps reduce model complexity and combat overfitting. The alpha value can be tuned to find the optimal balance between bias and variance. And now coming for the fitting the model. So model.fit, and in that we have X train and Y train that trains the ridge model on the training data. It adjusts the weight of the feature in X train to predict the Y train while also considering the regularization term. This helps prevent the model from fitting too closely to the noisy aspects of the training data. And then we are re-evaluating the model. After making adjustments, it's important to re-evaluate the model again using the same cross-validation technique to see if the issue of overfitting has improved. And then we have visualization. To help illustrate overfitting, you could create a plot showing the training and validation errors over the number of epochs or model complexity. So by using these techniques, you can identify if a model is overfitting and take steps to correct it, ensuring it performs well not only on the training data but also on new unseen data. So now moving to the next question, that is question number 3, and it is based on real-time data stream processing. And the question is, you are tasked with building a model to predict stock prices in real time. The data comes in every second and you need to update your predictions accordingly. Describe how you would set up your system to handle this type of data effectively, and what tools and techniques would you use and why. So you could start answering this question with handling real-time data. So handling real-time data, especially for something as volatile and fast-paced as stock prices, requires a robust system that can process and analyze data quickly and accurately. So here's how you could approach this. We will set up such a system and we will have some steps. So starting with the steps. So the first step is choosing the right tools. The right tool would be Apache Kafka. So this is a popular tool for handling real-time data that streams because it allows you to publish and subscribe to streams of records, that is data, and it can handle high throughput with low latency. Kafka acts as a buffer and manages the flow of data, ensuring that your system doesn't get overwhelmed. And you can also use Apache Spark. Especially Spark streaming is excellent for processing the data. It can process data in real time and perform complex operations like windowing, grouping data into chunks of a specified time period, and aggregating, that is summarizing data. So you can modify it and perform the predicting of stock prices. And then the step is data processing pipeline. And the first step comes here is ingestion. Data first enters the system, typically through Kafka, which collects data sent from the stock market. And then we do the processing. So Spark streaming takes over here. Here you can apply transformations and run your predictive models on the data. For example, you might calculate moving averages or other indicators that feed into your stock price prediction model. And then comes the output. Finally, the predictions are outputted. This could be to a dashboard for traders, an automated trading system, or even stored for further analysis. And then we develop the model. Now comes the model development. You would likely use a machine learning model that can update quickly and incorporate new data as it arrives. Models such as ARIMA for time series forecasting or more complex machine learning models like recurrent neural networks (RNNs) can be suitable. The model should be retrained or fine-tuned periodically with new data to ensure it stays accurate. Now we'll come to scalability and reliability. So ensure your system can scale as data volume increases. This might mean adding more servers or optimizing your data processing code. Implement monitoring to catch any issues early, like delays in data processing or model performance drops. And now we'll see the step, that is visualization and monitoring. Consider setting up a real-time dashboard that shows key metrics like prediction accuracy and processing time. This helps in quickly spotting when something goes wrong. By setting up your system with these tools and strategies, you can effectively handle the challenge of predicting stock prices in real time. So now we will move to the next question, that is question number 4, and this will be based on scalable data analytics. So we have covered two questions that were a bit code-based questions, and now we'll see other questions that would be based on scalable data analytics, or they might be on different areas. And with the 13th question, we will start again with the coding ones. So moving with the question 4, that is based on scalable data analytics. And the question is, given a scenario where your organization suddenly needs to scale its data analysis capabilities due to an influx of data that would be 10 times the normal volume, how would you handle this situation to ensure your data analytics processes remain efficient and accurate? What technologies would you consider and what steps would you take? So you can start answering this question with, handling a sudden increase in data volume requires a strategic approach to scaling your analytics infrastructure without compromising on efficiency or accuracy. So we'll see some steps from that you could effectively manage this scenario. That you would start answering the interviewer that we can start by evaluating the current infrastructure's ability to handle increased loads. This includes assessing your databases, servers, and analytical tools to identify potential bottlenecks or limitations. Then you could move to next step, that would be choosing scalable technologies. To manage the increased data volume, consider leveraging cloud-based solutions such as Amazon Web Services, Google Cloud Platform, or Microsoft Azure. These platforms offer scalable resources which can be adjusted accordingly to the data load, ensuring you only pay for what you use. Integrate big data technologies like Apache Hadoop for distributed storage and Apache Spark for fast data processing. These tools are designed to handle massive volumes of data efficiently and can scale up to meet standard increased demands. Now we'll move to the next step, that would be optimizing data processing. So implement data partitioning and indexing strategies to improve the efficiency of data queries. This will help in managing large data sets by breaking them into smaller, manageable chunks and speeding up search operations. And use real-time data processing frameworks like Apache Kafka or Apache Flink, which can handle high throughput and provide timely insights from large data streams. And the next step would be automation and monitoring. Automate routine data processing tasks to reduce the manual effort and speed up the analysis. This can be done through scripting or using workflow automation tools. Set up comprehensive monitoring systems to track the performance of your data processes. Tools like Prometheus for system monitoring and Grafana for analytics and monitoring dashboards are useful here. They help ensure that the system is running smoothly and alert you to potential issues before they become critical. And the next step will be regular evaluation and scaling. Continuously evaluate the performance of analytics infrastructure. As your data grows, keep adjusting and scaling your resources to maintain optimal performance. Plan for periodic reviews of your technology stack and infrastructure to ensure they remain aligned with your data needs and organizational goals. By following these steps, you can ensure that your data analytics processes are prepared to handle sudden surges in data volume effectively, maintaining the integrity and speed of insights. So this was all for the question 4. Now moving to the question 5, and this is based on integrating machine learning models into production. And the question is, you have developed a machine learning model that performs well in testing environment. Now you need to integrate it into your production environment where it will be used in real-time applications. What steps would you take to ensure the successful deployment and operations of the model in production? So we'll start answering this by successfully deploying a machine learning model into production involves several critical steps to ensure it performs as well in real-time operations as it does in testing. So you would have a clear pathway to make the interviewer understand. We will start with the pathway with the first step, that would be model validation. So before moving anything into production, revalidate your model's performance using a separate validation dataset. This helps confirm that the model generalizes well to new, unseen data. The next step will be preparing the production environment. Ensure that the production environment is ready to handle the model. This includes setting up the necessary hardware and software, ensuring that it can handle the expected load and that all dependencies are correctly installed and configured. Then the next step comes, that is model wrapping. Wrap your model in an API, that is application programming interface, making it accessible to other parts of your software infrastructure. Frameworks like Flask for Python can be used to create a simple web server that listens for data inputs and provides model outputs. Then comes the next step, that is deployment strategies. Consider using containerization tools like Docker, which can help encapsulate your model and its environment, ensuring that it works uniformly across different development and production settings. And then we'll use deployment strategies like blue-green deployment or canary releases to minimize downtime and reduce the risk of introducing a faulty model into production. And then comes the next step, that is monitoring and logging. Implement logging and monitoring to track the model's performance and health in real time. Tools like Prometheus for monitoring and ELK, Elasticsearch, Logstash, Kibana for logging help in quickly identifying and diagnosing issues in production. And then comes the next step, that is performance tuning. Monitor the model's performance over time. If the model's performance degrades or if new data shows different patterns, you may need to retrain or fine-tune the model to maintain accuracy. And after this step, there's a step for feedback loop. Set a feedback loop where predictions and outcomes can be compared. This feedback is crucial for continuously improving the model and catching any drift in data or changes in external conditions that affect the model. And after this comes a last step, that is legal and compliance checks. Ensure all the data used by the model in production complies with privacy laws and regulations. This is crucial for maintaining trust and legality, especially when handling sensitive information. So by carefully planning and executing these steps, you can smoothly transition your machine learning model from a testing environment to a fully functional component of a production system. So this was all about the question number 5. Now moving to the question number 6, that would be based on data-driven decision making. And the question is, your company wants to shift towards more data-driven decision making. You have been tasked with developing a strategy to implement this. What steps would you take to ensure that the data at all levels of the organization is utilized effectively to make informed decisions? And what challenges might you face and how would you address them? So you can start answering this by implementing a data-driven decision-making strategy that will require a comprehensive approach to ensure that reliable data is accessible and effectively used across all levels of the organization. And now we can develop and deploy this strategy, and similarly you could tell this strategy to the interviewer. So the number 1 step will be assessing current data infrastructure. Start by evaluating the existing data infrastructure to understand what data is available, how it is stored, and how it is currently used. This assessment will help identify gaps in data collection, storage, and access that need to be addressed. Now we'll move to the next step, that is developing a data governance framework. Implement a data governance framework that defines who can access data, how it can be used, and who is responsible for maintaining its quality. This framework ensures data integrity and security, which are critical for making reliable decisions. Now we'll move to the next step, that is training and empowerment. So train employees at all levels on the importance of data-driven decision making and provide them with the tools and knowledge necessary to analyze and interpret data. This might include training sessions, workshops, and ongoing support to ensure everyone can use data effectively. Now moving to the next step, that is implementing analytical tools. So deploy user-friendly analytical tools that can integrate seamlessly into the daily workflows of employees. Tools like Tableau, Microsoft Power BI, or even advanced Excel techniques can provide powerful data analysis capabilities without requiring extensive technical knowledge. After this, we'll move to the step that would be creating a centralized data platform. Develop a centralized data platform where all organizational data can be accessed and analyzed. This platform should be scalable and secure, providing a single source of truth for the organization. And then we have the promoting a data-driven culture. So foster a culture that values data-driven decision making. Encourage experimentation and learning from data-driven initiatives. Celebrate successes and learn from failures to continually improve the use of data-driven in decision making. And there would be some challenges and solutions for that. So one major challenge we know here is resistance to change, as some employees may prefer traditional decision-making methods. So address this by demonstrating the tangible benefits of data-driven decisions through pilot projects and success stories. So data silos can also hinder effective data use, promote cross-department collaboration, and integrate disparate data sources to overcome this challenge. After that, you can monitor and do continuous improvement. So by systematically implementing these steps, you can transform your organization into one that leverages data at all levels to make informed and effective decisions. And after answering in these steps, you could make the interviewer have a truth and a faith in you that you could make these models. Now moving to the next question, that is question number 7, and that is based on handling large data set. And the question is, your project involves analyzing extremely large data sets potentially exceeding terabytes in size. What strategies would you use to manage and analyze such large data sets effectively? Describe the tools and techniques you might employ. And you could start this with answering that working with large data sets, especially those in terabyte range, presents unique challenges in terms of storage, processing, and analysis. So we'll have a structured approach to handle these challenges effectively. We'll start with the data storage, that would be use distributed file systems. Consider using a distributed file systems like Hadoop Distributed File System, HDFS, or Amazon S3. These systems are designed to store vast amounts of data across many servers, offering high availability and fault tolerance. And then comes the next step, that is data processing. Leverage big data processing frameworks. Tools like Apache Spark are ideal for processing large data sets because they handle distributed computing effectively. Spark can perform data processing tasks much faster than traditional disk-based processing due to its in-memory computing capabilities. And next we could start with efficient data sampling. So there are many sampling techniques that we can use. So when the data set is too large to handle, even with powerful tools, consider using data sampling techniques to reduce the size to a manageable level without losing significant insights. Ensure that the sample represents the whole data set accurately. And then comes optimization of data queries. Indexing and partitioning. Optimize your data queries by implementing indexing and partitioning. This can drastically reduce the time it takes to perform queries by limiting the amounts of data scanned. And then we can do scalable analytics. And then we'll move to the next step, that is scalable analytics. And in that we could start with the parallel computing. Use parallel computing capabilities of frameworks like Spark or Dask to analyze data across multiple nodes. This helps in scaling up your analytics operations to handle large data sets effectively. And now we'll move to the cloud-based analytical tools. So consider using cloud services like Google BigQuery or AWS Redshift, which are designed to handle massive data sets and complex analytics with ease. And after this step, we'll move to data cleaning and pre-processing. Here we will automate pre-processing tasks. We'll use automated tools to clean and pre-process data. This includes handling missing values, normalizing data, and removing duplicates, which can be particularly challenging with large data set. And after this step, we'll move to the step that will visualize large data set. So we'll use specialized tools. That tools could be Tableau or Power BI that can handle large data set by aggregating data and using efficient back-end technologies. For more detailed exploration, tools like Plotly or Bouquet can be used as they offer capabilities to interactively visualize large volumes of data. And after that, there would be step for regular maintenance and updates that could be continuously monitoring the data quality. As new data comes in, you can continuously monitor its quality. And after this step, you could integrate all these strategies and tools into your workflow, and you can effectively manage and extract valuable insights from extremely large datasets, thereby supporting robust data-driven decision making. And you could answer the whole strategy to the interviewer. Now moving to the question number 8, that is based on optimizing machine learning models. And the question is, during model development, you have noticed that your machine learning model is underperforming. What steps would you take to diagnose the problem and optimize the model's performance? What techniques and tools would you use? So you can answer this by starting with the optimizing. And optimizing a machine learning model that is underperforming involves several steps to diagnose and improve its accuracy and efficiency. And here we will have structured approach to tackle this issue. And you could start this with the number 1 step, that is diagnosing the problem. Evaluate model metrics. Start by thoroughly evaluating the performance metrics of a model. For classification task, look at accuracy, precision, recall, and the F1 score. For regression task, consider R squared, mean squared error, that is MSE, and mean absolute error, that is ME. And then you can move to the next step. That is, use plots like ROC curves for classification models and residual plots for regression to visually assess where the model is going wrong. After that, we'll move to the next step, that is data quality and quantity check. Inspect the data. That is, sometimes the quality and quantity of data can be the root cause of poor model performance. Ensure the data is clean, well pre-processed, and sufficient. Look for issues like missing values, outliers, or imbalanced classes. And after this, we'll move to the feature engineering step, that would be experiment with creating new features or transforming existing ones to provide better predictive power. And then we have the next step, that is model tuning and configuration. After feature engineering, we'll move to the next step, that is model tuning and configuration. So hyperparameter tuning. Use techniques like grid search or random search to find the optimal settings for your model's parameters. Tools like scikit-learn's grid search CV or randomized search CV can automate this process. And there's a cross-validation that would implement cross-validation to ensure that the model's performance is consistent across different subsets of the dataset. And then we have the next step, that is trying different models. So experiment with algorithms here. If initial models are underperforming, try different algorithms that might be better suited for the problem. For instance, if you started with linear regression and it's not performing well, consider more complex models like random forest or gradient boosting machines. And after this, we have ensemble methods that we can use techniques like bagging, boosting, or stacking to combine the predictions of multiple models to improve overall performance. After this step, we have feature selection that includes reduce dimensionality. Use techniques like principal component analysis, that is PCA, to reduce the number of features, which might help in improving model performance by removing noise and redundancy. And then we have select important features. So use model-based technique to identify and keep only the most important features that impact the outcome. And then comes the last step, that is regular updates and retraining. So here you can monitor and update, that could be continuously monitoring the model's performance over time. As new data becomes available, update and retrain the model to adapt to any changes in underlying patterns. And after that, you could have a consultation and collaboration work with the other teams. And by methodically addressing each of these areas, you can diagnose why your machine learning model is underperforming and can take steps to optimize its accuracy and efficiency. So this was all about question number 8. So let's start with the question number 9, and this is based on handling unstructured data. So the question is, you are given a large amount of unstructured data, including text, images, and videos. What strategies would you use to manage and analyze this type of data effectively? Describe the tools and techniques you might employ. So you can start answering this question by describing that dealing with unstructured data can be challenging due to its lack of predefined format or structure. However, with the right strategies and tools, you can effectively manage and analyze it to extract valuable insights, and there will be an approach how you can do that. So we will discuss the approach here, and starting with the steps. So the number 1 step will be data categorization and organization. So the number 1 step in this step will be sorting and tagging. We will begin by categorizing the data into types, that will be text, images, or videos. Use tagging to add metadata, which helps in organizing the data and makes it easier to access and analyze later. After that, particularly for text data, we'll use natural language processing, NLP. We will employ NLP techniques to extract useful information from text. Tools like NLTK, Spacey, or even more advanced models like BERT can help you perform tasks such as sentiment analysis, entity recognition, and topic modeling. After that, we will do text indexing. We can use Elasticsearch or Apache Solr to index large volumes of text. These tools provide powerful search capabilities and can handle complex queries efficiently. And after that, we'll move to image data. And to structure image data, we'll use image processing. We'll use libraries like OpenCV for basic image processing tasks such as filtering and transformations. For more advanced image analysis, consider deep learning models using frameworks like TensorFlow or PyTorch. And then we'll feature extraction. Apply techniques to extract features from images, such as edges, textures, or key points, which can be used for further analysis or machine learning. And then we'll come to video data. And here we'll do video processing, and we'll use the tools like FMPEG that can be used for basic video processing tasks such as format conversion or extracting frames. For analyzing video content, look at machine learning models that can classify or recognize activities in the video. And after this, we'll move to temporal analysis. For videos, temporal components are important. Techniques like sequence modeling or recurrent neural networks, RNNs, can be useful to analyze sequences of frames for activities or events. And then we'll move to data storage and management. Here we'll use the given volume and complexity of unstructured data and use big data platforms like Hadoop or cloud services like AWS S3 for storage. These platforms can scale up to handle large data sizes and provide the necessary infrastructure to store and retrieve unstructured data efficiently. And then we have visualization and reporting. Custom dashboards that we'll create here. We will develop custom dashboards using tools like Tableau or Power BI, which can integrate different data types and provide a unified view of the analyzed data. And after that, we will do data summarization. Tools that provide summarization capabilities can help in considering large volumes of unstructured data into more manageable and interpretable forms. And after that, we'll leverage these strategies and tools and can effectively manage, analyze, and derive insights from unstructured data, which can be crucial for making informed decisions in various applications. And this is the path that you can explore and explain to the interviewer if this question has been asked. Now moving to the question number 10, and that will be based on scaling AI solutions in enterprise. And the question is, your company wants to scale its AI operations from a few initial pilot projects to enterprise-wide implementation. What are the key considerations and steps you would take to ensure the successful scaling of AI solutions across the organization? And what challenges might you face and how would you address them? So you can start answering this question with the scaling AI solutions. You could answer him that scaling AI solutions across an enterprise requires careful planning and strategic implementation to ensure success and alignment with business objectives. And there should be a strategic approach to implement this. So starting with the approach, and the number one step will be strategic alignment. So identify business objectives. Start by identifying the business objectives that the AI solutions are intended to support. This ensures that the AI initiatives are aligned with the company's strategic goals and can demonstrate clear business value. And then comes the stakeholder engagement. So engage stakeholders from various departments early in the process to gather input and build support. This helps in understanding diverse needs and ensures broader acceptance of the AI solutions. And after that comes the infrastructure and technology. So there's an option that is assess and upgrade infrastructure. Evaluate whether your current IT infrastructure can support the expanded use of AI. You might need to upgrade hardware, invest in cloud solutions, or adopt technologies that facilitate AI processing and data handling. And after that, we have standardization of tools. Standardize the tools and platforms used for AI development to ensure compatibility and ease of maintenance across the organizations. And after that, we'll move to data management. So robust data governance, that is to implement a strong data governance framework to manage enterprise data effectively. This includes policies for data quality, security, and compliance, especially important when scaling AI solutions that rely on vast amounts of data. And after that, we will come to data accessibility. So ensure that data is accessible across the organization, but also secure against unauthorized access. This involves setting up secure data lakes or warehouses that centralize data while allowing controlled access. And then we come to the next step, that is talent and training. So build AI competency, that is develop in-house AI expertise through training programs and hiring. So this builds the necessary skills within the organization to develop, manage, and scale AI solutions. And after that, you can also perform cross-functional AI teams. That could be forming cross-functional teams that include data scientists, IT professionals, and domain experts. So this fosters collaboration and ensures that AI solutions are developed with a comprehensive understanding. And after forming these collaborative teams, we'll move to scalable deployment models. So pilot test and phased rollout. Before a full-scale rollout, conduct pilot tests to gauge the AI solution effectiveness and integration capabilities. Based on feedback, adjust and then gradually deploy the solutions across the organization. And then we have modular and flexible design. So design AI systems to be modular and scalable, allowing for adjustments and expansions as needs. And then we'll monitor and do the continuous improvement. So there will be performance metrics that would establish metrics to regularly assess the performance of AI systems. We will monitor these systems to ensure they met expected outcomes and adapt as necessary. And after that, we have next step, that is addressing challenges. So there could be cultural resistance, that there could be employees that would be resisting to the changes, but we have to address this through continuous education and by showcasing successful AI use cases within the organizations. And by carefully considering these aspects and methodically implementing steps, you can successfully scale AI solutions across your enterprise, driving significant business value and innovation. And that's all for question number 10. Now we'll move to question number 11, and that is based on ethical considerations in data science. So the question is, in your data science projects, how do you ensure that ethical considerations are addressed? Describe the steps you take to identify and mitigate ethical risk in your projects. What frameworks or guidelines do you follow? So you could start answering this question with ethical considerations, that they're crucial in data science to ensure that the solutions and analyses do not advertently cause harm or bias. Here's how you can ensure that. So there are some steps and we will discuss those steps, starting with the number one, that is educate on ethical standards. So stay informed about the ethical standards in data science, such as fairness, accountability, transparency, and privacy. Organizations like the Data Science Association and the ACM have codes of ethics that we refer to as guidelines. And then we have ethical risk assessment. Identify potential ethical issues. That would be at the beginning of each project, conduct a thorough assessment to identify any potential ethical risk, such as biases in data or impact on vulnerable groups. This involves reviewing the source of data, the methodologies used for data collection, and the intended use of the data analytics results. And then we have stakeholder analysis. Engage with stakeholders to understand the diverse perspectives and potential impact of the project. This helps in identifying ethical issues that may not be apparent from a purely technical standpoint. And then we'll move to mitigation strategies. Implementing bias mitigation techniques, we will use statistical and machine learning techniques to detect and mitigate biases in data. This might involve techniques like resampling, reweighing, or using algorithms designed to be fair. And then we have privacy preserving methods. Employ methods such as data anonymization, encryption, or differential privacy to protect individual privacy when analyzing sensitive data. Then we have other methods, that is transparency and explainability. There we have model explainability, and after that coming to documentation and reporting. So we have to maintain thorough documentation of data sources, model decisions, and methodologies. And then we have continuous monitoring and feedback. There you have to monitor outcomes and the feedback mechanisms should be applied. And then we have the panels, that is collaboration and advisory panels. Then we have ethical review boards. So for complex projects, setting up or consulting with an ethical review board can provide oversight and diverse perspectives on the ethical implications of project methodologies. So by proactively addressing ethical considerations through these steps, you can ensure that your data science projects uphold high ethical standards and positively contribute to society while minimizing harm. So this was all about question 11. Now moving to question number 12, that is based on time series forecasting for business decisions. So the question number 12 is, you are tasked with forecasting monthly sales for a retail company using time series data from the past 5 years. What steps would you take to prepare and analyze this data to make accurate forecast? What specific tools or techniques would you use and why? So we can start answering this by time series forecasting. And we could address them that it's a powerful tool for predicting future events based on past data, especially in business context like retail sales. So we will have a structured approach here, and we'll start with data collection and cleaning. First, we will gather data and ensure that you have collected all relevant data, including monthly sale figures from the past 5 years, and also considering including external factors that might affect sales, such as economic indicators, holidays, and promotional activities. And then we'll proceed to clean data. We'll check for and handle any inconsistencies or missing values. And then we have data visualization. Here we will plot the data. We'll use plotting libraries like matplotlib or seaborn in Python to visualize the data. This will help in identifying patterns, trends, and seasonality. And then we have decomposition of data. So there's a seasonal decomposition, and we'll use statistical techniques to decompose the data into trend, seasonally, and residuals. So this can be accomplished with tools like the seasonal decompose function from the stats models library in Python. And we'll understand these components separately and can improve the accuracy of our forecast. And then the next step is model selection and forecasting. So there are two models, that is ARIMA and SARIMA models. So we have to choose appropriate forecasting models based on data's characteristics. For instance, ARIMA, that is autoregressive integrated moving average. It is effective for non-season data, while SARIMA, that is seasonal ARIMA, that is suitable for data with seasonal patterns. And after choosing the model, we'll move to cross-validation. We will implement time series specific cross-validation techniques like time-based splitting to evaluate model performance. And this will ensure your model generalizes well on unseen data. And then we have model fitting and diagnostics. We will fit the model, that is by using the Cinemax class from stat models that will fit your model to the data. And then we will carefully select parameters based on AIC, that is Archaic Information Criterion, that scores or thorough grid research technique. And then we can do the diagnostics and forecast and validation. And after forecast validation, we'll move to iterative improvement. So there's a feedback loop that should be mandatory, and there should be a regular update for the model with new sales data and refining the model as needed. So this continuous improvement cycle helps adapt to changing patterns in sales data. And by following these steps and using these tools, you can create robust forecasts that help the retail company plan better and make informed decisions. So this was all about question number 12. Now moving to question number 13, that is based on customer segmentation using machine learning. So the question is, you are given a data set containing demographic and purchasing behavior data for a group of customers. Your task is to segment these customers into distinct groups based on similarities in their purchasing behavior and demographics. So what steps would you take to perform this segmentation, and can you provide a sample Python code snippet to illustrate the initial stages of data handling and model application? So we can start this by explaining customer segmentation, that it's a powerful approach to tailor marketing strategies and improve customer service by identifying distinct groups based on their behavior and characteristics. And here also we have a detailed approach for this task. So we'll start with number one step, that would be data exploration and pre-processing. So there will be initial exploration, that is beginning by examining the data set to understand the features available such as age, income, purchase frequency, etc. Then we'll look for missing values or anomalies and decide how to handle them. That could be using imputation. And then we'll move to feature engineering. We will create new features that might be useful for segmentation, such as customer lifetime value or average transaction amount. We'll also use normalization, that is normalize the data to ensure that one feature doesn't disproportionately influence the model due to its scale. We'll use standard scaling or min-max scaling as appropriate. So then we'll come to the next step, that is choosing the segmentation technique. And here we have k-means clustering. So this is a popular method for customer segmentation. Here we will decide on the number of clusters by using techniques like the elbow method or silhouette analysis to determine the optimal cluster count. And then we have model implementation. And in that we will use data preparation, and we'll prepare the data by selecting the relevant features and applying any final transformations. And then we have model fitting. We'll fit the k-means clustering model to the data and evaluate and interpret analyzing clusters. And after analyzing clusters, we'll move to the next step, that is strategic insights. We'll provide actionable insights based on cluster characteristics such as targeted marketing strategies for each segment. And then we have iterative refinement, that is feedback incorporation, and we'll use business feedback to refine the segmentation. If additional data becomes available, incorporate it to enhance the model. And now we'll see the sample Python code. So for this, first we'll import the libraries and modules. As you can see on the screen, we have imported pandas, random forest classifier, train test split, standard scalar, classification report. And after that, we'll load the data And for that we have used the pandas to read the data, that is read underscore ssv. And after that we are processing the data, that is data pre-processing. We are handling missing values and using the forward fill or FIL to fill missing values in the data set. And then we are featuring scaling, that is normalizing the selected features, that is feature 1, feature 2 and feature 3 using standard scaler. And then we'll move to the next step, that is data splitting. We'll split the data set into training and testing sets. So that test size equal to 0.2 parameters specifies that 20% of the data will be used for testing. And then we'll train the model. We'll initialize and train a random forest classifier with 100 trees and a random state for reproducibility. And then we'll evaluate the model. We'll make predictions on the test set, that is x underscore test, using the trained model, and print a classification report showing precision, recall, F1 score and support for each class. So this code demonstrates the process of loading, pre-processing, training and evaluating a machine learning model, that is random forest classifier, for predicting equipment failures in a manufacturing plant. The use of techniques such as data pre-processing and splitting along with the random forest classifier highlights a standard flow for building predictive maintenance models. So this was all about the question number 13. So now moving to the question number 14, that is based on predictive customer churn. And the question is, you are tasked with developing a model to predict which customers are likely to churn from a subscription service. So what steps will you take to build this model, and can you provide a sample Python code to illustrate the data preparation and model training process? So we'll start answering this question about depicting what is predicting customer churn. So predicting customer churn is crucial for businesses to implement retention strategies proactively, and we'll have a detailed approach for building a predictive model for this purpose, starting with data collection and exploration. And in this we will collect data, and after that we will perform the exploratory data analysis, that is EDA. We'll perform an initial analysis to understand patterns and trends. And then we have feature engineering. We will create new features and derive new features that might influence churn, such as change in usage pattern or service upgrades. And then we'll handle the missing values if we found any. And then we'll encode categorical variables. We'll use techniques like one-hot encoding or label encoding for categorical variables. And then we have scale features to normalize or standardize numerical features to ensure they contribute equally to the model's performance. And then we'll select the model, that is, we'll choose the appropriate model and start with for the knowing handling binary classification task. That could be with logistic regression, random forest or gradient boosting machines. And after selecting the model, we'll train the model and evaluate it. So fit your model on the training data, and after that evaluate the model using appropriate metrics like accuracy, precision, recall, F1 score and ROC to gauge its performance. And then we'll optimize the model using hyperparameter tuning. We'll optimize the model parameter using grid search or random search to improve performance. And then we have feature importance, that is analyze and rank features by their importance in predicting churn to refine the model further. And then the last step is deployment and monitoring. We'll deploy the model. Once validated, deploy the model into a production environment where it can predict real-time churn. So after deploying the model, regularly monitor the model to ensure it remains effective over time as new data comes in. So now we'll see the sample Python code for this example. So starting with the importing of libraries, we will import pandas, numpy, scikit-learn, sklearn, tensorflow, and the tensorflow keras and callbacks. And after importing the modules, we'll start with data loading. We'll load the dataset from a CSV file named equipment_data.csv, and that too with the pandas data frame. And after that we'll do the data pre-processing. We'll handle missing values, and for that we'll use forward fill to fill missing values in the dataset. And then we have feature scaling that will normalize the selected features, that is feature 1, feature 2, feature 3 using standard scaler. And after that we'll use the data splitting. We'll split the dataset into training and testing sets, and the test size will be equal to 0.2. And this parameter specifies that 20% of the data will be used for testing. And after that we'll start with building the model. First we'll see sequential model that initializes a sequential model technique. And then we have dense layers that adds 2 dense layers with 64 units and ReLU activation function. Then we have dropout layers that adds 2 dropout layers with a dropout rate of 0.5 to reduce overfitting. After that, we'll do the model compilation. We'll compile the model using the Adam optimizer and binary cross entropy loss function for binary classification. And there will be an early stopping that will define an early stopping callback to stop training when the validation loss metric has stopped improving after 3 epochs. And after training the model, we will evaluate the model and evaluating the model on the test data and print the loss and accuracy metrics. So this code demonstrates the process of loading, pre-processing, building, compiling, training, and evaluating a deep learning model using TensorFlow and Keras for predicting equipment failures in a manufacturing plant. So the use of techniques such as data pre-processing, dropout, regularization, and early stopping helps in building a robust deep learning model for predictive maintenance. So that's all with question number 14. Now we'll start with question number 15, that is based on deep learning in NLP. And your question is, you are tasked with developing a sentiment analysis model using deep learning to understand customer opinions from reviews. So what steps would you take to build this model, and can you provide a sample Python code snippet to illustrate how you would pre-process data and train a simple deep learning model? So we'll start answering this with sentiment analysis. That sentiment analysis using deep learning allows businesses to gauge customer sentiment from text data like reviews or comments effectively. And we'll have a detailed approach for building a sentiment analysis model. We'll start with data collection and cleaning. We will collect the data, gather a substantial data set of text reviews and their associated sentiments, typically labeled as positive, negative, or neutral. And then we'll clean the data, pre-process the data by removing noise such as HTML tags, special characters, and stop words. And we'll normalize the text by converting it to lowercase. And then we have text pre-processing. We'll convert text into tokens, words, or phrases. And then we have vectorization that transforms tokens into numerical format using techniques like word embeddings or TF-IDF, that is term frequency inverse document frequency. And then we'll use the padding. And then we have the option of model selection. We'll choose a model architecture based on a basic approach and use a RNN or more advanced architecture like LSTM, that is long short term memory, or GRU, that is gated recurrent units, which are effective for sequence data like text. And then we have model training. We'll compile the model, define the model architecture, and compile it with the loss function suited for classification like categorical, cross entropy, and an optimizer like Adam. And then we'll train the model, we'll fit the model on our pre-processed data. We'll evaluate and optimize it. Evaluating model performance, here use the metrics such as accuracy, precision, recall, and F1 score to assess the model. And then we have hyperparameter tuning. We'll optimize the model by adjusting parameters like learning rate, number of layers, and units per layer. And then coming to deployment. We'll deploy the model and integrate the model into the existing review processing pipeline so it can automatically classify new reviews. So let's see the sample Python code, and we'll have a basic approach for that. Here we'll import NumPy, TensorFlow, sequential, embedding LSTM, dense dropout. So embedding converts positive integers, that is indexes, into dense vectors of fixed size. And LSTM, that is long short term memory layer, that is used for learning dependencies in sequence data. And then we have dense, that is a regularly dense connected NN layer. And then we will import pad underscore sequences. And after that we have the data set and the sample text data representing customer reviews that will store in variable text. And then we have labels that has binary labels indicating sentiment, 1 for positive, 0 for negative. And now we'll start with the pre-processing of data. Here we have declared that tokenizer. We will initialize a tokenizer that will help only the top 1000 most frequent words. And then we have fit underscore on underscore text, that is update the internal vocabulary based on the list of text. It essentially creates a dictionary of word to index pairs. And then we have text to sequences that will transform each text in text to a sequence of integers. And then we have pad sequences that will ensure all sequences have the same length by padding shorter sequences with zeros up to the maximum length. And then we'll start building the model. Here we have sequential model that will set up a linear stack of layers. And then we have embedding layer that will map each word index to an embedding vector of size 64. So the input length is set to 10, that is the length of the input sequences. Then we'll start with LSTM layers. So 2 LSTM layers are added. The first one returns sequences to allow the next LSTM layer to process these sequences. And after that, we have the dropout layer that applies dropout with a rate of 0.5 or the first LSTM layer to reduce overfitting. And after that, we'll come to dense layer that has output of a single scalar that represents the predicted sentiment and using sigmoid activation to output a probability. And now we'll start with model compilation and training. So we'll configure the model for training and we'll use binary cross entropy as the loss function that is suitable for binary classification and the Adam optimizer and tracks constantly accuracy as a metric. And then we have the fit that trains the model for a specified number of epochs, that is iterations or the entire data set. And then we'll predict the model, that is after training the model can predict the sentiment of the reviews in the dataset. This is useful for checking how the model performs on the training data itself. So this breakdown explains each step of the coding process, detailing how the data is prepared and how the model is configured. And then we'll compile it and use for training and prediction. So its detailed explanation should help in understanding how to implement a simple LSTM model for sentiment analysis in TensorFlow. Now moving to the question number 16. So let's start with question number 16, that is based on anomaly detection in transaction data. So the question is, you are tasked with identifying unusual transactions in a company's financial data that might suggest fraudulent activity. So what steps would you take to develop an anomaly detection model, and can you provide a sample Python code snippet to illustrate how you would pre-process the data and apply an anomaly detection technique? So we'll start answering this with anomaly detection technique. That is, anomaly detection is essential for preventing fraud by identifying transactions that deviate significantly from typical patterns. And now we'll see the structured approach to building an anomaly detection model for transaction data. We'll start with data collection and cleaning, and we'll collect all the compiling transaction data, which should include details like transaction amount, time, user ID, and transaction type. Then we'll move to feature engineering and develop features that capture the essence of transactions, such as time of day and the day of the week. And then we have data normalization. We'll use scaling techniques such as min-max scaling or standardization to ensure that the model is perfectly normalized. And then we have choosing the anomaly detection technique. So here we have to choose the technique which is effective for high dimensional data sets and works for isolating anomalies instead of profiling normal data points. After choosing the anomaly technique, we'll train anomaly identification. We'll fit the chosen model to the data, and the anomalies that would have been chosen will be those transactions that the model identifies. And after this, we come to the last step, that is review and action. Here we have manual review, that is transactions flagged as potential anomalies should be reviewed manually to confirm fraudulent activity. And then we have continuous improvement. That is, we can regularly update the model with the new data and feedback from the review process to improve accuracy. And now moving to the prediction, that is after training the model, we can predict the sentiment of the reviews in the dataset. And this is useful for checking how the model performs on the training data itself. Now we'll see the Python code to see how you can set up this model for anomaly detection. We'll start by importing the libraries and module, and after that we'll load and prepare data. That is, we'll load transaction data from a CSV file into the pandas data frame. And after that we'll convert the transaction time column to date time format, which allows the extraction of additional time-based features. And after that we'll perform feature engineering that will extract the hour of the day from the transaction time column. This feature can be important as transactions occurring at unusual hours may be indicative of fraud. And then we'll move to the normalization of data. This will apply standard scaling to the amount and hour of the day feature. This normalization process involves subtracting the mean and dividing by the standard deviation for each feature, ensuring that the feature contribute equally to the analysis and improving the performance of many machine learning algorithms. And after that, we'll start with anomaly detection with isolation forest. That's a technique. We will initialize an isolation forest model with 100 trees, that is n estimators equal to 100, setting the proportions of outliers, that is contamination, to 1% of the data. So this parameter is crucial as it influences the threshold of marking an observation as an anomaly. Then we'll fit the model to the scaled amount and hour of the day data and predict the anomaly status for each transaction. And then we'll start with filter and display anomalies. We'll filter out transactions identified as anomalies, that is anomaly equal to -1. We'll display these transactions which can be reviewed manually to determine if they represent actual fraudulent activity. So this code snippet provides a systematic approach to detecting anomalies in transaction data, leveraging the isolation forest algorithm's ability to handle complex and high-dimensional data set effectively. So the pre-processing steps ensure that the data is appropriately formatted and normalized for optional model performance. So this was all about question number 16. Now moving to question number 17, and that is based on integrating machine learning models into web applications. And your question is, you have developed a machine learning model to predict real estate prices based on various features like location, size, and amenities. How would you integrate this model into a web application to allow users to get real-time price predictions? Can you provide a sample Python code snippet to illustrate how you would prepare the model for integration and handle user requests? So starting with the approach, that is integrating a machine learning model into a web application, this will involve several steps to ensure the model is accessible and perform well in a live environment. So here's how you can approach this task. We could divide into steps, and we'll start with number 1 step, that is model preparation. We'll finalize and save the model. So once your model is trained and validated, save it using a format that can be easily loaded into a web application. So Python's pickle module or TensorFlow's save model format are commonly used for this purpose. Then we can use web application backend setup. For this, select a suitable web framework. So Flask is popularly known for its simplicity and effectiveness in integrating Python-based machine learning models. And after that, we'll develop the API. After developing the API within your Flask app, that you can receive user inputs for model features, load the model, make prediction, and return the result. And after this, we'll develop the UI. We'll design a user-friendly interface. We'll create a simple and intuitive UI that lets users input the feature like location, size, and submit them for prediction. And after that, we'll move to the deployment phase. We'll use a cloud platform like Heroku, AWS, or Google Cloud to deploy your Flask application. And then we have the maintenance and updates. We'll monitor and update regularly for the performance and use the model as needed based on user feedback. So now moving to the Python code and see how this model can be created. So here we'll start importing the libraries and module, and we are using Flask, Pickle, and JSONify. And we will start with app initialization. We'll initialize a new Flask web application. That would be a special variable which gives Python files a unique name to differentiate between them when they are imported into other scripts. And after that, we'll load the model. So loading a pre-trained machine learning model from the file system. So this model is assumed to be saved in the same directory as this script. So the model is loaded in RB mode, which stands for read binary. And after that, we'll move to API route and prediction function. So we will define an API endpoint at predict that listens for post request. This is the URL that the front end of the web application will call to send data to the backend. And after that, we'll start with predicting the function. And here we have extract features that retrieves data sent into the JSON format from the post request. That is request.get_JSON, and the force we have set it as true here, and forcefully formats the request data into JSON, ensuring compatibility. And then we'll extract the relevant features, that is location, size, and amenities from the JSON object and store them in a list as expected by the model. And after preparing the features, we'll make the prediction. We'll use the loaded model to make a prediction based on the provided feature. And then we have the return prediction method. Here we will convert the prediction result into JSON format using JSONify and send it back to the client, and this will ensure that the response can be easily handled by the client application. So this was all about the question number 17. Now moving to the question number 18, that is based on analyzing. And now we'll move to the question number 18, that is based on analyzing geospatial data. And your question is, you are tasked with analyzing geospatial data to help a city improve its public transportation system. The data includes GPS coordinates of bus stops, ridership numbers, and traffic patterns. What steps would you take to analyze this data, and can you provide a sample Python code snippet to illustrate how you might visualize bus stop location and ridership? So you can start answering this question, that geospatial data analysis can provide critical insights into how effectively a public transportation system serves its city and guide improvements. And there's a detailed approach for this, and we can start with data preparation. And in this, we will do data collection and data cleaning. And after this step, we will move to the next step, that is exploratory data analysis. And in this, we will have statistical summary, we will generate descriptive statistics, and then we have correlation analysis. And after moving that, we have geospatial visualization, that is mapping bus stop. We'll plot the locations of bus stop on a map to visually assess their distribution across the city. And after that, we have heat maps that will create ridership data to identify hotspots and areas with potential service gaps. And after geospatial visualization, we'll move with spatial analysis. We have proximity analysis that will analyze the proximity of bus stop to key areas like commercial centers or residential areas. And now moving to the fifth step, that is optimization and recommendation. So we'll have a route optimization that will suggest modifications to route based on traffic patterns and ridership demand. And the policy recommendations that will provide actionable recommendations for improving bus frequencies. Now moving to the sample Python code where we can define this model and use it accordingly. And here we will start importing the libraries and modules. And here we'll start with importing GeoPandas and matplotlib.pyplot. And after importing, we'll start with data loading. So we will declare a variable bus underscore stops and load the bus stops data from a shapefile. So shapefiles are popular geospatial vector data formats for geographic information system software. And then we have the ridership that will load ridership data from a CSV file which includes columns for longitude, latitude, and ridership levels. And after that, we'll create geodata frame that will convert the ridership data frame into a geodata frame. And this step involves creating a geometry column from the longitude and latitude columns. And then we have the plotting one. Here we will plot the graphs that would be figures and axes and create a figure for the single subplot with a specified size that is 10 cross 10 inches. And then we have city underscore map.plot. It is assumed that there is a base map of the city loaded as a geodata frame named city map. This is plotted first with the light gray color to serve as a background for the other layers. So this was all about question number 18. Now moving to question number 19, that is based on predictive maintenance using machine learning. And the question is, you are tasked with developing a predictive maintenance system for a manufacturing plant that relies heavily on automated machinery. So the data available includes machine operational parameters, maintenance history, and failure incidents. What steps would you take to develop a predictive model, and can you provide a sample Python code? So you can start with predictive maintenance that is essential in manufacturing as it helps prevent equipment failures, reducing downtime and maintenance cost. And here you would have a detailed approach or predictive model for this, starting with data collection and integration. Then you can do EDA, that is exploratory data analysis, and then we can perform feature engineering and then move to data pre-processing tasks and then the selection model and training. And after that, we have model evaluation and deployment technique that we can do for the model using appropriate metrics such as precision, recall, and F1 score. So this was all about question number 19. So now move to question number 20, that is based on personalization using machine learning. And your question is, you are tasked with developing a machine learning model to personalize content recommendations for users on a media streaming platform. The data available includes user demographic details, viewing history, and ratings. So what steps would you take to build a model for personalized recommendations? And can you provide a sample Python code for that? So you can start answering this with creating a personalized recommendation systems. This would be essential for engaging users by providing content that is relevant to their interest. And there will be a systematic approach for personalized content recommendation. We'll start with data collection and integration. And after that, we'll perform EDA, that is exploratory data analysis. And then we have feature engineering. In this, we'll interact features and the temporal features. We'll include time-based features to capture trends and seasonality in viewing behavior. And then we'll select the model, that is by collaborative filtering and hybrid models. And then we'll train the model and validation and implement and monitor them. And after that, we'll deploy the model, integrate the recommendation system. And with that, we have come to the end of this session. If you have any doubts, comments, then comment down in the comment section below and our experts will be happy to help you as soon as possible. Thanks for watching and stay tuned for more from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.